Dear friends, welcome to another video. In this video, I am going to show you how to connect a Nokia 5110 LCD display with a Raspberry Pi Pico board. I'll also show you how to use it with CircuitPython, and I will share with you 4 small projects to help you get started. Let's start. The Nokia 5110 display is probably my favorite display. I have used it in many Arduino projects in the past and I really like it because it is inexpensive, it costs just around $4, it is very easy to use, it has a very low power consumption and it is readable under direct sunlight. The display has a resolution of 84 by 48 pixels, it is monochrome and it uses the SPI interface to communicate with the microcontroller. The connection with the Raspberry Pi Pico board is very easy. All we have to do is to connect 8 wires. The first pin of the display is the reset pin and we connect it to the GP17 pin of the board. The second pin is CE. CE pin goes to GP18 pin of the board. The next pin is DC. DC pin goes to pin GP16. The fourth pin is DIN. DIN goes to the MOSI pin of the board, which is pin GP11. The next pin is clock, and we connect it to the GP10 pin of the board. The next pin is VCC, and we connect it to the 5V output of the board, the V-bus pin here. The next pin is light, which controls the backlight of the display. If you want the backlight to be on, connect this pin to ground. If you want the backlight to be off, leave it unconnected or connect it to the 3.3V output of the board. If you want to control when it is on or off, connect it to any available GPIO pin of the board. I am connecting it to ground to turn the backlight on in this video. The last pin is ground and we connect it to ground. Our connections are ready. Let's power up the board to see what happens. As you can see, the display works and it displays a demo script, a rotating 3D cube. Cool! Let's now see the software we need to drive this display. In order to use this display with CircuitPython, we need to download 2 libraries, the Adafruit PCD8544 library and the Adafruit FrameBuff library. To install the libraries, we have to download the CircuitPython libraries bundle for this link and unzip it on our computer. Since I developed all the projects using CircuitPython 8, we need to download the bundle for CircuitPython 8. Now, all we have to do is to locate the needed libraries and copy and paste them inside the lib folder in the CircuitPy drive. Additionally, we need a font file. In the CircuitPy drive, we also have to copy the font 5x8 bin file if we want to use text in our project. Your CircuitPy drive should now look like this. We have a code.py file with the script to run on the board, a font file, and a lib folder with all the libraries required. You can find links to all the files needed in the video description. The first example program is a rotating 3D cube, the code of which is a slight modified version of the rotating 3D cube for MicroPython. I'll post a link to the original code in the video description. The second example is a demo program by Adafruit which draws some shapes and some text on the screen. As you can see, the text which is displayed is small inside. I needed a bigger font size, like the one I used in my Arduino projects. Unfortunately, a font like this is not available, so I created my own from scratch and I developed this simple thermometer project. This project does not require an external temperature sensor since it uses the temperature sensor that exists on the Raspberry Pi Pico board. The temperature sensor is not very accurate, but this project is just a demonstration. As you can see, the temperature is displayed using a big font and a thermometer icon is displayed next to it. Cool, we now have a big font available. In order to replicate this project, all you have to do is to copy the PCD8544 graphics.py library I created and the image.py file that contains the thermometer icon in the CircuitPy drive. In a future video, I can show you how to convert and display any graphic on the Nokia 5110 display using a converter I developed. Let me know if you are interested in the comment section. The last project I'm going to share with you is this simple bouncing box program. I wanted to see if CircuitPython is fast enough to develop some games with this display. It turned out it is. The display is the problem, since it can't keep up with frame rates higher than 10 FPS. It produces noticeable ghosting. But I'll try developing a simple Pong game and see how it goes. CircuitPython makes development much easier, so if you haven't already tried it, I suggest you should give it a try. Of course, using CircuitPython requires knowing how to code in Python, which is another headache if you are not familiar with Python. In that case, don't worry, the fundamentals are very easy to learn. I have prepared a detailed course on my second channel about Python programming. It will teach you the basics in just a couple of hours. If you are interested in learning Python or CircuitPython, check it out now. I think it will help you a lot. Now that we know how to use the Nokia 5110 display with CircuitPython, we can use it in our projects if we want a low-cost, low-power display. My first goal is to develop a Pong game with it, as I already mentioned, and then to recreate the famous Nokia Snake game. I can't wait to see this project completed, so if you don't want to miss any of those projects, consider subscribing to the channel. Thanks for watching, and I'll see you next time.